identify characters in TV series using only subtitles. So our goal is to label all face tracks in the TV series, and the way we want to do that is to use only the subtitles, so only training. But first I want to talk to you about other we'll get some weekly labeled data for like who speaks what, and subtitles contain information align the. For example, we have here we have in the transcripts Ahi Leonard, and we get information of Penny and the timestamp. Using lip movement estimates, these can label the corresponding face track with. So what we want to do is only to rely on the subtitles to get theory.
Hey, Leonard.
Good afternoon, Penny. So, hi.
So even if you have never watched The Big Bang Theory, still we're able to learn the names of these two characters. So it should be possible only to use the dialogue and the video to learn the name of the characters. You don't need any transcripts or manually annotated data. So what we have done is only to use the subtitles. We processed the subtitles. The only thing that we needed was name mentions. So the only sentence that contain name mentions. And these name mentions we classified into first, second, and third person. First person name mentions is when a character is talking. Second person name mentions is when a character is talking. And third person name mention is when a character is talking about another character that isn't involved in the conversation, like Leonard can process car. Using the person number and the name mentions, we integrated all of this into a multiple instance learning framework. Namely, we create labeled bags. We have noticed that when we have first and second person name mentions, the character is usually present in the scene, and third person name mention usually infer that the character isn't present in the scene. So using this, we were able to create the bags. A bag is a collection of instances, which is in our case face tracks. The bag also contains a name, a bag name, and a label that can either be positive or negative. But a bag is positive if there is one or more of the face tracks that correspond to the bag name, and a negative bag is if none of the face tracks can be associated with the bag name. So if we have first and second person, we create positive bags because usually it infers that the character is present in the scene. And if we have third person name mention, we create a negative bag. So we collect all face tracks in that scene, label the bag with the corresponding character name, and label it negative. Using these bags, we were able to train multiple instance learning models. And using the MIL models, we then were able to weekly annotate all the instances in those bags. And these then were afterwards used to train SVM models that were able afterwards to annotate all character appearances in the TV series. We evaluated on 3 different TV series: The Big Bang Theory, Buffy the Vampire Slayer, and Lost. Here you can see in the first table the quality of our bags. We only have put here the percentage of correctly labeled bags and the density of positive tracks. And in the second table, you can see our final results, and we have obtained an average precision of over 75%. And thank you.